Hi everyone, in this video I will discuss the solution to the problem split linked list alternatingly. And in this problem you will be given a head of a single linked list and your task is to complete the function alternating split list and that split the given single linked list into two smaller lists. One smaller list contain all the nodes which is at odd position, and another smaller list will contain all the elements which are at even position. And you have to return an array containing the head of both the sub-linked list, and the sublist should be in the order with respect to the original list. So let me explain you. There's a first sample test case. So for the first sample test case, this is the linked list which is given to you. So here, this is the node which is at position 1, then position 2, 3, 4, 5, and 6. So what you have to do, you have to create one smaller list which has all the elements, all the nodes which are at odd position. That is this node, then node which is at position 3, then position 4, alternative, and then another small list which contain all the node which is at even position. So this 2, then position 4, and position 6. So here you can see we have a 0, 0, and 0 at odd positions, and we have 1 at even position. So I hope you get this problem statement. And here I will discuss the solution, which takes a linear time, and constant space, that is auxiliary space complexity is constant. And how we can solve this problem in just a constant extra space. So instead of creating a new linked list and copying the elements, what I will do, I will update the original linked list so that all the positions which are odd are linked together, and all the even position will get linked together. So how I can do this thing? So for that we need two variables. So let's say we have a head of this linked list. So this is the head. So first what I will do, I will use a pointer variable, let's say named as a, for odd position linked list. So I will initialize this a with head because the first node is at position 1 which is odd. Cool. Then another pointer variable, let's say b, which will store the head of even position linked list node. And here I will initialize this one with head dot next because this is the first even position. Cool. So we have this a here, and we have b over here. Cool. And then I will use variable current and initialize this current with head, and I will make the changes in this original linked list. Cool. So instead of current is equal to head, so instead of writing this as head, let's say this is current. So current is equal to head. Now we are at odd position, and then what I have to do, I have to remove this connection and I have to make this connection, that is connection from 1 to 3, because our goal is to connect all the nodes which are at odd position together, and all the nodes which are at even position in a separate list. So instead of creating copy and copying the values, what I will do, I will update this original linked list. Cool. So to make this connection, we first have to store the node which is at even position, because if you directly change this connection, this connection, then you will lost the access to this node too. Also, you have a pointer variable b which is pointing to 2, but let's just store this as of now for a better explanation. So first I will store the address of next even position node. It is simply equal to current. If current is a odd position, then current dot next is a even position, and then I will change the address, and that is stored in a current. That is, I will remove this connection, and then I will make this connection, that is from odd to next odd. So from 1 to 3. And how we can write in terms of a code? So it is simply equal to current arrow next, which is previously pointing to node 2, and now it will point to current next next. So next is even and its next is odd. So the next node of 1 is 2, and the next node of 2 is 3. That is next odd element, next odd position node. Cool. And then what I have to do, I have to just simply change this. I have to change this connection, that is from 2 to 4. I have to change this connection. So for this thing, what I can say, I can just simply say current next, not current end, not current next, but it is temp next, and temp which has now initialized with a even position node. Here we have our temp. So I will change this temp dot next to current next next. That is from 1 from 2 to 4, because current next is 3 after this thing, the current next is 3 and 3 next is 4. That is next even position node. Cool. And then I will move this current. So current is equal to temp, not temp, but current is equal to current arrow next, not temp. That is take me to the next odd position node, and for the next odd position node, I will do the same thing. So here we got this thing, and let me write it. Draw this here from in this way. Then current is equal to current arrow next. So the next is P. So here we have our current, and then what I will do, I have to make. I will simply remove this connection and make this connection from 3 to 5 next odd position. So before this thing, I must have to store the next even position node, which is this 4. So temp is equal to current arrow next. This is the first step. Then the second step, change the connection. So from here, from this 3 to 5, and then what next? And then after this, I have to change this connection. That is from 4 to 6, next even position. So from 4 to 6. Cool. So 4 to 6. This is the third step. And then take me to the next odd position node. Next odd position node is 5. So current is equal to current arrow next. So which is 5. So now here we have our next odd position node, which is 5. And then what I will do, so after this 7 we have a null. After this 7 we have null. So first I will store this next even position node. So this is my temp, and then I will make the changes. That is I will remove this connection, and from 5 to next odd position, which is 7. Cool. And then from 6 to next even position, and the next even position we have null. So I will just simply make this connection, that is from 6 to null, because we do not have any other even position node. So then this is the third step. This is the third step, that is a temp next, which is pointing to 7, and now I will just change it to current next, which is 7, and its next, which is null. So I will remove this connection and make this connection. And then what I will do, I will, in the next iteration, before the next iteration, I will move this current to current arrow next. So the next is 7. The next odd position node is 7. So the next odd position node is 7. So this is the value of current, and basically this is the termination condition. I will perform these 4 steps while current not equal to next, current not equal to null, not next, and current current arrow next not equal to null. If we do not have any even position node after the current, then we don't have to make any changes. And here I can draw this separately. So this address of 6 is storing null, and the address segment of the 7 is also storing null. That is this is same as our requirement. Now we have this two smaller sublists, and there is one edge case which is missing here. Before accessing this thing, that is here now only I am checking for current arrow next, but here you are checking current arrow next. So make sure to only make a connection if current arrow next not equal to null. That is before this thing, I will add one more condition, that is if current arrow next is not equal to null, because there might be a case when the current arrow next is equal to null. Current arrow next not equal to null. Then only I will make this connection. Cool. And this is the complete explanation. The time complexity is linear, and no extra space, because we are making changes in original linked list, so that's why it is constant. And here is the implementation. So here we have our pointer variable A for odd position, then we have a pointer variable B for even position node, and current is equal to head, then the same condition. And this is the first step. I will copy the next even position node, and then I will change from the current odd to the next odd, and if current next not equal to null, then I will make this connection, that is from temp next event to next event, and then take me to the next odd position node, and then I will simply return a comma b. Let's just try to submit this, and successfully submitted. So thank you so much guys for watching this video, and have a good day.